Thomas, for the very kind introduction. It's great to see a bunch of familiar faces and names here. You know, a lot of the stuff that we've learned over the years actually has been inspired by some of the people here in the group, like Yong and Alex, who I see are on the call. So it's exciting to have them on that and informing us. So a little bit of background. Let me share my screen here real quick while I talk. Let's see, I think that's it. So my name is Oppenheimer. I'm the CEO and founder of Algorithmia. I've been in the data analytics tooling space essentially my entire career, now rather long. Started in Wall Street doing data analytics for equities desks, then moved on to, got brought to Seattle by Microsoft. Spent about 6 years at Microsoft building out some tooling around, kind of like data analytics tooling inside Excel, SQL Server, a product called Power BI. We worked on the V1. So super exciting. So look, for me, making tools that make sense of data is my passion. It's what I love doing. And it's been an interesting journey to understand this kind of like what I would call the new chapter in data analytics, which is machine learning and the potential it has. And one of the big beliefs that I have, and obviously my team has, is we're looking at the most revolutionary technology that we will see in our lifetime happening in front of us. I mean, like, this is going to affect everything from the digital to the physical world, and it's kind of amazing to see how it's evolving in front of us, and kind of exciting to be part of that. So I have a pretty illustrious audience here, so I do want to put some kind of like things behind. So I took the chance when I was talking to the list of what I was putting together was to take a little bit of a negative approach on why projects fail. And why we don't, like, now that we all agree that this is the greatest technology ever. Now we can start talking about, well, why are we not seeing it in production, and what happens, and what are the problems that happen around that? And so this is kind of experiences that we've learned. A lot of it has to do with people and not technology, as you've all probably suffered throughout your careers, that a lot of the problems are not technology problems. And so that's kind of where I'm going to focus today's talk on. So to kind of start out, and this is really obvious, but I always like talking about this, which is, if you're going to leave today with anything, if you understand anything, is that machine learning and production machine learning are two completely different beasts. And that's, if you learn, in most of my talks, I say, hey, if this is the only thing you take away, I've done my job. And so a lot of it is going to start talking about, hey, what are the considerations? What are the problems that happen in production machine learning that might not be just considered in the typical machine learning process? So we obviously think about data collection, data cleansing, and building out, kind of how we build out the model, and accuracy rates and explainability. But what we don't think about is infrastructure and orchestration and integration into DevOps tools, and how does my company deploy software on a daily basis? And one of the things that I've kind of continuously talk about is, in the world of BI, which was my traditional kind of like background, the delivery of ROI was at what I call the screen, right? There's a report, there's a dashboard, you're answering a question around data. In the world of machine learning, the delivery, right, the ROI happens when the model is being used in some way, or pipeline is being used to make predictions inside software. So integration into software is the ultimate goal. And we have to start thinking with that mentality of, how do we integrate things into software? How do we participate in the software development lifecycle of an organization? And how do we grab things that are very different in the world of machine learning and start integrating them into that lifecycle? And so this is where I say kind of production machine learning is quite different. So high level, we do a survey every year. Over 500 practitioners participate in it. Again, this should be no news to anybody here, but 75% of the actual clock time that is being spent by machine learning and data science team is in infrastructure tasks, and not in actually building out new models, right? An infrastructure task can be everything from setting up environments to resolving dependencies to figuring out how this is actually going to go run. And some of the key challenges that have come up in these surveys are, the explosion of different languages and frameworks. We're moving at a pace I don't think we've ever seen in software a faster moving set of technologies than we are seeing day to day in machine learning, from a framework perspective, from a language perspective, from a library perspective. I mean, it's so exciting, but it's like every day something new. Like, we just figured out how to productionize that last thing. Now as the proliferation of models in organizations start happening, how do you actually start managing those models? How do you version them? How do you actually get reproducibility around them? And then scale, like when, we start looking at, I'm very curious to hear about, Bert, we actually just put Bert in production for a customer. So I'm really curious to hear what optimizations you've done there. I mean, these models are getting giant and they're really resource hogs, and they need to work, they need to respond and work in, millisecond latency. It's starting to become a real engineering challenge to actually get to the experiences that we expect our software to have, while doing it at the scale that our businesses run. And that's, where the key challenges are lying. So I just took this from Gartner, just to give you the idea. Where the main business barrier, what they're seeing from delivering business value, is actually successful, lack of successful productionization of projects. So we had the lowest number in the survey. So we said about 70% of projects don't ever make it into production. Gartner was saying something like 83. McKinsey was saying something like 90. I'm okay being the conservative one on this one. I want to have a little bit of a more positive spin on it. But it's amazing, like the amount of effort, if you think about the amount of projects that are going into it, the funding, the people, the operations around it, to see, anything that is, above a 50% failure rate is quite impressive, and needs to be kind of addressed around that. And there's obviously a number of reasons for that. So when we start thinking about, where most enterprises are, most of companies are really just starting. And I know a lot of you work at organizations and you've actually put your organizations in the sophisticated or at least early adopter case, having talked to some of you. But a lot of companies are just trying to figure out, hey, I know this technology is important. I know we need to be doing something with our data. How do we actually get to it and around that? How do we actually do that? In a lot of cases, this feels really core, like how we're going to make decisions with data, how we're going to apply ML is, we need to build the internal teams. So there's a whole process of hiring teams and training teams and understanding, and then getting those teams to actually work. I'm assuming some of you had this experience, but bringing an academic or somebody who has most of an academic background into a large enterprise and saying, hey, deliver stuff is quite a daunting task, especially when like you don't even know how to get things done in a large organization. You expect like, hey, I can't just roll this model on my laptop and deploy it to EC2. And then a really small amount of companies responded and saying, hey, we actually have anything deployed. We're talking barely double digits around that. And so when we started looking at it, again, this is nothing new to anybody. We started looking at like, well, how does software gain speed in an enterprise? How have we seen higher speed delivery of software in organizations? How do we see more things in production? And that highway inside traditional organizations is really the DevOps track. It's about building that high-speed highway of delivery of applications faster into production, building, testing, deploying, monitoring, having nice set out tracks. Now, the difference in the world of ML, again, I'm repeating things that most of you know, so I'm going to go quickly through this. That train, deploy, manage, train, deploy, manage is a much more iterative, speed than we've ever seen, even in traditional DevOps. The data changes, the data drifts, the calculations change. We have to consider different hardware. So not only is that path the fastest path we've ever seen in terms of iteration, we actually now have conditions that are changing constantly. So we've kind of like doubled up on the complexity of the problem. But at the end of the day, what we're looking for, the ethos behind DevOps really is, make a faster path to production so that we can actually iterate quicker, get better applications, move faster. And that's what's needed for machine learning to get into really production, and kind of like one of the things that, how are we going to actually go do that? So for those of you who have not read this paper, I highly recommend it. I mean, it's kind of old right now, but I mean, it's kind of like the core of everything I'm going to be talking about today, which is, the hidden debt in technical debt in machine learning systems. And, if you haven't read it, just kind of figure out like the ML code is not the problem, right? It's really everything else around it and managing it and how you actually do that. It's a really interesting paper. I highly recommend it. And kind of like the basis of a lot of the stuff that, I'll be talking about today. So, we're in this huge growth phase. We have a really difficult and expensive for DevOps to keep up. And a lot of it is just kind of like, if you think about how we do this, and this actually plays really well into Emmad's talk, which is, kind of evolving the infrastructure inside an organization. But like when you start, this isn't hard. You're all really smart engineers. Most of you here, like, who are engineers are really smart engineers. Getting a model, putting a Flask app, getting a Python, model inside a container, maybe putting an API around it, getting a VM, like this is not rocket science, right? Like this is doable. You can learn how to do it. Any of you can figure it out. You don't need a DevOps team. You're not really thinking about high availability. You're kind of doing everything manually. You might have a recipe to do it. It's not really a problem when you only have a few heterogeneous APIs. So now think about our scenario to give you a general idea. So Algorithmia.com, which is one of our products, it's a SaaS product for essentially deploying, serving, managing models. We have about 120,000 users on that platform. At any given time, there's about 2 to 3% of the population that's active on any given day. We have 11,000 models in production that need to be instantiated at any time an API hits, right? We have an SRE team of 2 people, right? So that's the scale that we actually look at from that. So when you have that, every single version, multiple versions of the algorithm, anybody can run heterogeneous frameworks, hundreds of thousands of developers, anything that could scale from 1 to thousands of times a second, a lot of variance, super low latency, multiple language. This is complexity, right? This actually becomes a really, really strong DevOps problem that you need to solve. And you need to solve it with really strict engineering because it's impossible to do what you were doing initially around kind of manually rolling through this. And this is what we think. We don't think we're special in this. We think this is where most organizations are going to end up. I see some folks from Lyft. I mean, I'm sure Lyft has hundreds of thousands, hundreds of models around, different things that they're calculating on a daily basis. Like this is a today scenario for a lot of organizations that need to actually build out muscle in this. This is not just a future state. So we talk about the iteration, right? Which is connecting to your data, getting those models trained, deploying them to production, scaling them, managing, reconnecting the data. And so getting this life cycle so that your applications are doing, it becomes actually important to separate it from a traditional app dev development. So one of the things for a reason is just acceptance testing. If you think about it, like how are you actually going to go, if you're going to actually say, hey, we're going to update our app every 5 weeks or every 6 weeks, your model might be 10 times over bad at that point, completely drifted, not really working. And so the iteration, and a lot of times separating, these out through APIs so that you can have a faster iteration process on the model build, development, and deploy becomes really important. Separating out from that ML, from the actual application creation. So I'm going to start talking about, I'm going to separate this into 2 things, a tactical view and then a more technical view of the problem. So why is today ML economically challenging? And this is across enterprises. This is kind of what we've seen. So the problems of why ML doesn't get into production, there's a lack of process. It doesn't exist, right? We are doing the wrong incentives, right? Which means we're actually producing saying, hey, just get something up, just get a POC running. We don't really know what we're going to use it. We don't actually understand how we're going to actually get value out of this, but let's just do it because it's cool technology and it's science, right? It's like treating it like science instead of treating it like an actual business problem. We're assigning the wrong teams to deal with the problem. We're getting the wrong technology, and we're actually having the wrong champions. So these are the core problems that are going on today and why models are actually not getting into ML is not being successful inside organization. So when we talk about lack of process, super easy to get POC funded. You go to the VP and say, hey, we're going to go do something. It's going to be cool. We're going to run a bunch of experiments. Great. So once you get the experiments and they run, what are you going to do with them? How are you going to affect the bottom line? What part of the P&L is going to be affected by this? What sales are we going to go up? What savings are we going to make? Is this understood? Who's actually going to fund production? Who needs to be involved to fund production? How are we going to do production for this? So the amount of projects that we observe where the figuring out of how this is going to go live is we're going to figure that out later is insanely high. And these projects fail at this is where the 90% comes in, right? Because getting funding for a project and experiment is actually really easy, but not thinking through how you're actually going to get it to production is a real problem. You have to start from how are we going to deliver this value to the organization and work backwards from there. So how do I go from POC to production? Well, first, plan and fund the deployment up front. Who's going to take this over? Who's going to be responsible for it? How we're going to actually do it? If we can actually make those measurements and the advances, how are we going to actually implement them? Set clear deployment criteria. Who's going to own this, how we're going to own it, how we're going to update it over time. You have to bring in the stakeholders from IT and DevOps early. Data science teams on their own, machine learning teams on their own, unless you're a very small startup, are not going to be successful at getting through the red tape of IT in large organizations. They own the gates, right? They can shut down systems, they can put red flags around, they can put red tape. You're never going to get into production unless you're IT and DevOps team. Therefore, bringing them early, explaining to them how things are different, and being able to do that becomes really important. And then you want to build repeatability in the process. You know, the only truth that we have right now in this space is tomorrow you're going to have more models in production than you have today. So repeatability is important. Start thinking through that around how you're going to go do it. So wrong incentives. So when ML efforts are part of innovation mandates, right, they're designed to be out there. But this is, you know, if we want to get really, really like kind of like oversimplified about this, this is optimization technology. We're meant to be optimizing business processes. We're meant to increase revenue. We're meant to reduce costs. We're meant to be able to apply this to our business to be able to do things that we couldn't do before. So setting those goals to learn, innovate, and experiment are, if you just do that, you're not going to actually get results to the business. Instead, you want to set goals to deploy, affect company metrics, and align with the business, right? I love going to, and I see some of the folks in my team sign in. So like, you know, I tell them, go to the, you know, the IT owner, the owner of this business and say, how is this machine learning model going to affect your business? If we get this fraud model in production today, are you saving money? Yes. Okay, great. So then that means that every day you don't have this model in production, you're losing money. Is that accurate? Correct. That's an incentive, right? That's an incentive to go fund the creation of the model. It's an incentive to go fund the deployment and the entire process. So I really love this framework, by the way, and I totally stole it from a consultant called Ian Xiao. So I highly recommend you go check him out on Towards Data Science. So he calls it the minimal justifiable improvement tree. And what he says is, how do we start an ML problem thinking about how we're going to improve a business objective? Are we focusing on the right, you know, we're going to save $2 million in 6 months. Well, is that enough? If I need a data science team of 15 people and a DevOps team of 4 and an infrastructure, that is definitely not even close to enough savings, even if I did it over 6 or 7 years to be able to be justifiable. So start thinking, what is the objective of what we're doing, and determining, okay, what are the constraints around that? How we're going to actually go be able to do that, and say how we're going to go apply it. Then we move down and we say, okay, well, how are we going to do it? What's the business process we're optimizing? What's the technology stack that we're going to be using? Who's going to own it from an organizational perspective? And what are the key drivers for that performance? And then is when we start going into the technology and looking, do we have the right data? Do we have the right modeling tools? Are we going to get the right results that we want? Are we going to be able to provide that in the front and back end experience of technology? Including myself, every single approach until I looked at this was upside down. I started from the bottom and went up. And this is a problem, right? Because we have to understand what business we're going to affect and then build out the entire stack. So again, this is a great blog post. It's called ML is Boring. And I highly recommend going and checking it out, because I completely fell in love with this framework. And I think it's really excellent. It's what I've been giving to executives all the time around how they think about getting into production. So wrong team. Asking data scientists with a lack of engineering experience to build infrastructure. Teams with lack of DevOps experience never actually run a full-time system, never actually run high availability systems, are being asked to do tasks that are completely outside of their comfort zone, but also where their expertise is. And then you have an organization have had to bring in the DevOps team and the data science team, and we were the first time they met. Like, our meeting was the first time we met, was kind of crazy. Like, that was a really surprising thing to me, because I was saying, wait, how were you even thinking you were going to get this into production? Like, they own production. How are you going to get there, right? It's different from a stack around that. And so you have to be able to answer, do I have the right skill set to make a solution deployable in my organization? So one of the solutions is creating hybrid teams. A lot of the kind of like tech first companies are doing this. You're combining DevOps engineers with data scientists and software engineers, and you're creating these kind of like high performing teams. What you can't do is try to find these unicorns around people who know how to do machine learning and production and DevOps and software engineering. They do exist. They're really, really hard to find. I spent a lot of time with Yang, who's on the call, talking about this. Pretty much impossible to hire these humans. But if you do have them, keep them. So stop chasing unicorns. They're really hard to reproduce. And then software and platforms that enhance data science and ML team. This is where you go look for tooling to help you with data prep, tooling to help you with model training, tooling to help you with scaling and ML ops. Like, this is where you can actually accelerate the gaps inside your organization by saying, hey, where do I need to hire people because I'm providing a core value to it? And where can I actually just go buy, a solution that's going to help me at one of those pieces go out and do that. So lack of proper champions. And this, this is not special to machine learning, but it's particularly important in these very expensive science, kind of like very expensive kind of potential science experiments. Like the deployment of every new technology, a lack of champion is going to be a death kiss. You need the person who's seeing forward and saying, if this works, the business is going to improve because of this, and my bonus is going to be there. You need this at all times. Like, you always have. I ask that in every single question I have with executives. I'm like, how do I ensure your bonus this year? Right? Like, what's the fraud feature? What's the risk feature? How do you get your bonus this year? Because that's what I want to align myself as an organization. Because if you don't have those champions, it's really hard, right? This all looks like cost. This all looks like experiments. They all look like cost. You need a champion to drive through sometimes to be able to push that through. So, I have a quote here, like, any introduction of new ideas, tools, or processes, it creates a level of uncertainty due to skepticism, unfamiliarity, or misunderstanding. Fear your failure is going to get into the way of important and rational decisions. Doing nothing. So if you think about without a champion, like, doing nothing in a lot of large organizations is totally fine. Right? In a startup, obviously not, but it's totally fine. You can get away with it. We've all worked at large organizations where we know we could get away with that. So how do you get buy-in? Align values and interests, invoke the stakeholders up and down the command, and just really say, hey, how are you, I legitimately ask that question. It's a little bit brutish of me, but like I say, how do I ensure your bonus this year? I ask that question live in those meetings. There's some standoff reactions, to be honest, but maybe I'll get a little bit more finesse around it. Wrong technology. So the ML process, super nascent, lack of defined technology stacks and best practices. You're not building for repeatability, measurability, and auditability. Proprietary locking to tooling, either on a cloud provider or multiple cloud providers or a specific tool set. Not thinking about your access to data. If I only had access to this data, I totally could build a better model. Well, if you don't, you don't, right? And so that's a reality. Differences between prod and dev. So what's the best ML architecture for my organization is what you need to be able to answer. And so the solution is design to execute at scale, repeatability, and efficiently. I like to take the approach of what I call tightly integrated but loosely coupled, which means the components that you're going to use in your ML stack need to be tightly integrated through APIs and integration and programmability, but also you should be able to plug and play or replace any single component at any given time in the future. And I realize that I run a vendor company and I'm saying kind of like the opposite of what I'm saying, but this is the proper design of a stack, is to be able to say, hey, I'm going to build for the best in class tool for this piece of the stack. And if I need to pop it out and replace it, I absolutely should. We've seen success over the last 30 years of software development by doing that, right? Where we actually have built out a software development lifecycle with things like GitHub and Jenkins and monitoring tools. And we pick the best in class, and when it's not good enough, we replace it and put something else. So this idea of tightly integrated but loosely coupled. Replace or upgrade components and technologies, data sources need to evolve, and just anticipate that you're going to have a ton of tools. What you're using today is not what you're going to be using 6 months from now. We've seen that over and over and over again, from models to frameworks to training to data. And remain open to integration with a variety of in-house technologies. The less you need to replace internally in your organization, from a DevOps perspective, from a training perspective, anything, the less you need to replace, the less friction you're going to have in terms of getting out there. So just being tactical about what I need to add on becomes super important. So let's get a little bit technical, since this crowd is technical a little bit. So this is a complete oversimplification of the cycle, but one of the kind of like structures and stacks that we look at is we have pretty evolved data management systems. This is where we put all our ETL pipelines, our feature stores, our processing, our data warehouses. There's management systems for this. We're going to have multiple training platforms and frameworks, because this is kind of pretty good. And this is, again, this is focused on large enterprises. If you're a small company, you might only have one training system, but in most large companies, These are popping up in every corner. So understanding that your data management system are going to feed these training systems, you're going to build a whole bunch of stuff, and then your models need to be able to go and run in production. And there is a level of consistency that you're going to want in terms of production. And we've seen this, this is just borrowing it from the world of software development, where how you deploy a model, how you deploy applications, how do you monitor applications, how do you run applications. There's a consistency in that layer across the organization that usually gets managed by IT and DevOps, and then having your apps consume that. Again, this is obvious to all the folks here. Training and production are very, very different. Serving work behaves very different from the training platforms and the conditions that are needed for those things. Training, you get the long compute cycles, fixed loads, stateful, single user in most. In production, you're going to get really short compute bursts. You need super elasticity up and down, and it can be mostly stateless if you think about inference. In a pipeline, obviously not. And then many, many users, right? You're talking about, potentially hundreds of thousands of mobile users at the same time doing inferences against a model around that. So, oops, there you go. So heterogeneous tooling, and we've all seen this, right? Different dozens of language combinations, different hardware combinations, different languages around this, different dependencies. When you build out your stack, one thing is actually just making it all work the first time. Every single one of these dependencies needs to be upgradable, right? So when you're starting to think about, hey, I need to go upgrade dependencies or patch something, like this is a pretty laborious process just to get started on something simple. Everything one of these pieces needs to be able to do that. So how are you going to actually prepare for that? How are you going to actually prepare for consistency around it? This is one of the reasons why machine learning models are not getting into production, is that these systems are falling apart before production can actually be achieved. Composability. And this is, I think, Ahmad is going to actually talk way deeper about this kind of pipeline, but, just think about, machine learning models don't live in isolation. They're built out of pipelines. Every single one of those pipelines and pieces of the pipeline, you want the best piece for that, right? So how are you going to actually do composability? How are you going to actually grab your R model running on GPUs and posting that into your Python model running on scikit-learn, going into, so like now the complexity of this, if I look at the dependency tree, for any of you who actually submitted to a large organization where they say, can you list all the open source components and dependencies you have? Like, this is a pretty big spreadsheet just to get this in production at an organization, right? And think about it. Now I need to go upgrade every single one of those components. So diversity complicates auditability and governance. Like, how do I understand who's calling what, when, with what data, what time, what am I doing there? Who can access it? What are they accessing? How do I actually do that? One of the interesting things, this actually came from a financial services customer that we were talking to, so super hardcore security around dependencies and Python and packages and all of these things. And then their data science pipeline was just pulling stuff from PyPy, like just no checks whatsoever, like whatever. Like they were just like loading things into their Docker containers with absolutely no compliance. When the DevOps team figured that out, they almost lost their mind because they were like so focused on like the other piece. So how do you audit this? How do you do the governance of those dependencies and packages? How do you make sure that you're compliant with your organization's rules around that? Lack of reusability slows growth. Like, you don't need to rebuild this over and over again, especially extraction. So like, this is what pre-processing functions are my favorite to like talk about here, because we reuse them so many times in so many pipelines and we just rebuild them every time. Yes, it's easy to like open the file, copy, paste it. But now, again, every single one of those dependencies need to be updated. These should be reusable services that I can use in an organization for extraction and stuff like that. Measuring model performance, success and performance are very context sensitive. There's a lot of success factors. The example I like to use is, 90, in academia, going from 90% accuracy to 93% accuracy is a very valid pursuit, right? It's the pursuit of ultimate truth. And if it takes me 10 years to do that, it's probably worth it. Now, if it takes more than 7 milliseconds to do a response in the world of e-commerce, I don't care if it's 60%, right? It's a recommender, right? Nobody's gonna die if a recommender shows. I mean, Amazon, one of the most advanced machine learning companies in the world, still, I just bought a barbecue and it suggests me another barbecue. I don't get mad about it. Right. And so like the context, the business, the performance around accuracy, success are really dependent on the business. And so how do you measure that performance? How do you understand it? And how do you attack it at the different levels becomes super important as well. So considerations for operationalizing ML in enterprises: infrastructure agnostic deployment, multiple clouds, on-prem infrastructure, et cetera, collaboration and pipelining, What are your performance SLAs going to be like? What's your regulatory compliance going to look like? What kind of governance do you have? How are you going to pay for it, right? Because if you're running this entire infrastructure for an entire enterprise, who's running the, those expensive GPUs becomes important. So being able to do accounting, chargeback tracking, et cetera. And then security and authentication, right? How are you doing middleman proxies, private CAs? How are you getting software into a bank? Like that's one of the things that like I talk to a lot of companies, like how do you actually get your containers or your Docker registry into a bank? Like that's like going through a DMZ, right? And so thinking about how your models are going to go into production and what the libraries are necessary there becomes super important as well. And so how to navigate these common pitfalls. So Peter's a good friend, and I love quoting him. So I'll put his quote up there and then say, don't reinvent the wheel. Outcomes, not processes, is what matters. Don't try to be perfect. Say no to lock-in. Tools are not solutions. And audit honestly and revise constantly. This is how you can actually evolve into building and to actually getting models in production at large organizations. And as I said, if there's only one thing you remember today from this talk, and remember me for, I'm the guy who said machine learning, kept on repeating machine learning is not production machine learning. And with that, thank you so much for your time today. If you're interested in learning more about Algorithmia, I have to do the pitch here. We got a live demo. We have some white papers where we literally talk about this product agnostic way. So everything I talked about today, we kind of have white papers so you can kind of think about it. And we just bought a new one on build versus buy. So how you can consider if you want to build and buy and kind of how you have to do that. And that is all I have for today. I will take questions. Thank you so much for patiently listening to me. I have some credits. So. No question.
Don't be shy to
stunned everybody
and jump in
or bore them to death.
or if you're shy, post them into the chat. You can ask Diego very hard questions. He's prepared.
I'm happy to answer those. I'll stick around.
Strange silence. This has never happened. Everybody is now reading the DevOps paper. Oh, there you go. There are a few.
So one of the questions is, what are your challenges in productionizing deep learning? Well, so I think, like the core one, kind of that first one that comes to mind is, do I run around inference on CPUs or GPUs? And there's a decision tree around that, right? And so it's really a performance and a cost function. So we do this actually quite often, which is helping decide where I want to be running the inference of deep learning, because usually I'd say on Amazon today, I think it's like a 3x factor is the cost, maybe 4x. So it's somewhere between 3 and 4x on the cost. And so the question is, if I only get a 2x speed up, is it worth 4x the cost? And again, it goes down to the problem that you're trying to solve around that. What's the SLA you're looking to resolve? If you don't care about the SLA there, then it's probably not worth it. But if you do, then it becomes super important. So that's kind of like the first level of around that. A second one is, and this is one, anybody who's dealt with CUDA and has dealt with kind of GPUs has had the pleasure of learning this. Like, we don't really have really good memory management inside GPUs. Like, GPUs crash when you run out of memory. Like, the entire GPU crashes. And so how do you actually understand when your neural net is going to be growing in memory? What are the, can you start polling and understand what the normal distribution of that memory print is going to look like? And how are you going to avoid scenarios when you're going to have to crash and restart the GPU because you essentially ran out of memory? There's no real memory controls like we have for CPUs today. I hear there's new stuff coming out in CUDA that will help with that, but today it's kind of the Wild West. You're kind of on your own to manage that. So that's that. Then availability. So in Intel CPU processors, you probably have pretty good consistency. Kind of everything runs on everything. In the world of GPUs, you have some pretty breaking changes between the different GPU chipsets and the CUDA versions that you're using. And so that's another level of complexity. So that's kind of, I went the technical route of GPUs outside of cost, but that's kind of some of the ones that are there. So yeah, okay. So I'm gonna go in order here. So follow up. We're in BERT age. Once the clients, the quality of the models they want it. Challenge for us is what are the best practices? No one knows what's the best strategy. In short, can you guide what resources we can look up? Is there new technology on AWS, EIA? Any thoughts? And so I think on yeah. Well, I mean, look, I have to give you the pitch of we can very easily deploy your models for BERT on Algorithmia, and there's a blog post about it. So that takes 2 seconds to do, and you should check it out. Now, when you're looking at technologies, I think data access is going to be important. So who your customer is, where they're accessing data, like do you need to cross over networks? Do you need to cross over VPCs? Is that going to be okay? And where do you actually how are you going to actually run it? What are the applications we're going to be running off of these BERT models? Those are going to be the things I would start considering in terms of, because if you don't care about any of that, you're like, hey, we just have an API, we can just call it, we can send data, we're going to get an inference, we're going to get a result back. Then I would go for simplicity for you and cost, right? Simplicity and cost is really the two functions that I would look at, because you're like, hey, how do I offload the operational cost of this so I don't have to deal with it? And how does it cost me the least so I can have the largest margin, right? At the end of the day, I'm running a business. So that's where I would start with. If you start having kind of security, networking control, controls around that where the data is, then you kind of have to guide yourself through that and start making decisions around that. So while our product can run in Azure, in AWS, on-prem, you might have a special scenario where you want it to run specifically in AWS or on a server. Like if you're running I can't imagine like a BERT model, but like if you had a vision model that you're running on a factory line, you need to run in a box. Like those are the considerations that I would look at for that. How do you help address the cost of retrofitting Algorithmia into existing ML systems? So sure. So we actually like it's very easy because we actually have everything's driven through APIs. And so whatever you're training models today, you're going to have an output of that. I like to joke around that we're the only commercial company where you can train a model on SageMaker and deploy it to Azure. I'm sure neither AWS or Azure want to hear that, but it's true. Probably Azure wants to hear that. But so like we can do that, right? So our play is an integration play. It's very easy, so the cost is almost minimal. What you'll see is we have a very generic open API with templates, and so you just need to kind of grab today what your model is, bring in whatever dependencies are around that, and just deploy it, and then we can take it from there. So it's actually quite simple to do, but the devil's in the details. I'm happy to kind of dive online around that. We've built a system that allows you to bring in, so kind of technically how we've done it is we've created per framework and we update the frameworks. One of our pride and joys is that when PyTorch 2.0 came out, we had it live in production an hour later. And so one of the things that we've done is we've really optimized the base containers for almost every framework, and things like certain versions of CUDA and certain versions of BERT and stuff like that. And then allow you to add things on top of that, but you're starting from a highly optimized production container. Because one of the things that we saw in enterprises, I'm sure nobody here has ever done this, but they're like, hey, here's the container with my model, and it has like 50 gigs of dependencies because they downloaded literally all of PyPy and every single potential statistical library that they might even want to use. And those are impossible to productionize. So we started the other way around, which is start from a minimal and let you add base layer on top of that, which allows for high speed production around that.
Jake, I have a question here on video.
Yeah, please.
Hi, this is Shane. Yeah, I had a machine learning consulting business as well a few years ago, and curious to get your thoughts on this, especially when selling to enterprises and you have an executive sponsor. A lot of the thorny issues is setting the right expectations as to what the outcomes you plan to achieve or your investments will pay off for your machine learning endeavors. And one of the recurring questions that would be asked is, or I would ask them is, kind of what benchmarks are we looking to achieve, right? So I'm wondering if you can just talk a little bit about that in your experience, working across maybe different industries, or if it's industry agnostic. How do you sort of deal with those questions of setting the right expectations with your executive sponsors to help them feel very confident that there could be some some reasonable way of recouping the ROI on the investments they're planning on.
Yeah, that's a great question. So I actually focus on not talking about machine learning, which is an interesting approach. So I'll give you an idea of this. So we were talking with a large consulting firm that builds out anti-money laundering, anti-fraud and money laundering tools. And one of the big things is that they do is know your own customer. So for those of you, anybody who's working banking, like any bank has a kind of an obligation of understanding who is banking with them and understanding certain parameters of that so that, they're real people, et cetera, and stuff like that. So what's the exposure that an organization has when they do that? And this is a chief risk officer type problem, which is they can get fined, right? And the fines are deep, right? Like you can get fined $1 million per customer per year that you don't know your own customer information. So when we talk about ROI, right, and we talk about investment, we say, okay, what's your exposure from not knowing your own customer? And like, let's forget about that we're going to do this with ML or that you're going to hire, 400 magical elves to go do this for you. That's irrelevant, right? Like the problem here is how are you actually going to get to that end use, which is you need to have 10,000 accounts that you're exposed on right now checked for. Okay, great. So your metric is reduction of exposure. So now how do you actually do that reduction of exposure? Well, I can go do it manually. You can go hire a BPO firm. You can go hire a consulting firm. They might do it for anywhere between $35 to $105 per customer, right? And a know your own customer transaction is usually a search on the internet, a preparation of a folio, and doing some NLP searches and building out this is the person, entity, account, process, and putting that in a package. So that's kind of like the overall workflow. It's very NLP based. And now you say, okay, well, we can do this. We can make you compliant in 5 days versus 200, right? When doing it with humans. And we can do that at $7, right? The interaction. So now the conversation was, around value was, okay, what's the risk I'm willing to take between 5 days to get to compliance or 200 days? So 195 days of non-compliance. That's where the value is. That's where the money is, right? That's where and so as long as your entire build out of the machine learning workflow is less than 195 days of non-compliance, going back to that tree that I showed, like that's where you make that justification. So it's hard, don't get me wrong. Like this is not an easy, like kind of value attachment because it's a lot easier to try to say, look, we're 2 seconds faster. Is that not value? But those are the KPIs that I indicate to the things saying, hey, look, you're going to get your satisfaction rating on your e-commerce on up to 95%, and that that's a conversion rate of X. You're going to reduce your security exposure because of this. And those are the ones that are driving real value today in the world of machine learning inside these organizations. So that's kind of how I would frame it. Does that answer your question?
Yeah, it does. Sorry, I don't mean to hog the time here, but one of the complementary questions that goes along with it is, which makes it hard to have this value conversation about of building an ML system to solve a business problem is, the outcomes are still questionable, right? Because everything it's not deterministic; it's all probabilistic. You don't know whatever. In the example that you gave, if you're building an NLP model, we're not sure as to how good the data is, what algorithms would work, and what level of accuracy will your model give you that would justify, even achieving those 5 days of automation, right? So I think that's like the second part of it. It gets even more trickier. That while the value conversation is great, I mean the executive can answer it. Usually the questions are followed by saying, well, how confident are you that your models can even hit, a reasonable level of accuracy that would give you those 5 days of automation?
Right. And again, I would double down on saying that's where the work backwards model works well, right? Because now you're saying, okay, this is what I need to get for the investment to be worth it. And now I'm looking at, what's the state of the art, right? Oh, state of the art is an accuracy of, 67%. And I'm saying, unless I get to 70, I'm not going to, I'm not going to get ROI. Well, then why even start? Not today.
Yeah.
Right? I mean, like leave that for somebody in academia who will spend years studying that, and we'll get to it eventually, and then you go implement it.
Eventually, right.
But I think, that's why starting back, because it's like, the problem is that like when you start going and saying, hey, I think we can just keep going, we're going to get better, and we keep going and get better, like it's a fallacy, right? I mean, you can get in certain use cases. I mean, it's not an absolute truth, but like, again, you're going into projects without, you know, where the goalposts are continuously moving from a results perspective. You're never going to make that customer satisfactory, right? Because, you know, unless you get, get lucky. So being able to understand, hey, what we're going to go do, you know, the other consequence of that movement, which I thought is really funny, in a lot of cases, like, you just go back to a rule-based system and you get just as good results, and it's way cheaper. And why is that a problem? Right? Like, you know, like we don't need to apply ML to everything. I mean, I want to, don't get me wrong. I'm a nerd. I love it. Like, I want to, but like, you know, it's just, you know, sometimes you're going to get the just as good results with rule-based systems, and that's perfectly fine. And, you know, why wouldn't we go to that? So
thank you.